A very good morning, all the students. I hope every one of you is in your best health. So, we were doing the chapter 4, that is carbon and its compounds. And in this chapter, we'll be learning about properties of carbon and its compound. Since our topic is covalent bond for today, and we have already learned about ionic bonds. The ionic bonds are the chemical bonds formed by the transfer of electrons of two atoms. That means when two different atoms combine, so they combine by the transfer of electrons, which happens basically in metals and non-metals. So covalent bond is little different than ionic bonds. As in the covalent bond, there is the formation of sharing of electron. So this is also a chemical bond, but here there is no transfer of electrons, but there is sharing of electrons of two atoms. So the definition goes as the chemical bond formed by the equal contribution of a mutual sharing. Now the term here mutual is that both of the atom needs electrons, and in order to have the electrons, they share the electrons from which both of them gets benefit mutually. So there is a mutual sharing of electrons between two atoms so that both the atom get their octet complete. Since we know that the configuration of the atom is such as K, L, M and N shell. So in the first shell is K shell, there is only duplet, and in the second shell is octet. So the atoms wants to acquire the nearest stable noble gas configuration. So for that they try to complete the octet or their duplets. So they share the electrons to acquire the stable electronic gas configuration. So for that they share the electron. So after that comes the terms covalency. Now valency, we all know that the valency is the combining capacity of an atom. That means any atom combined with how many electrons is known as its valency. For example, oxygen has valency 2 because oxygen has 8 electrons in its outermost, in its all the shells. That means the configuration is 2 and 6. 2 electrons in the K shell and 6 electrons in the outermost shell. But the valency is 2 because oxygen requires 2 electrons to complete its octet structure. Since oxygen has atomic number 8 and it wants to have 2 more electrons, so it gains 2 electrons and the number of electrons becomes 10, and it requires a negative charge. So the covalency is the number of electrons contributed by the atoms of element for sharing. Now valency is something which can be transferred. Example, oxygen has valency 2. So oxygen will take the electrons from any other metal such as magnesium. So that is called as its valency. But the difference between valency and covalency is just that in the covalency, the element does not transfer or does not gain, it just shares the electron. For example, if we talk about valency of chlorine, so it is 1. So chlorine has covalency 1 because when chlorine share 1 electron from its own atom, that means chlorine is a diatomic gas. As we know that chlorine has 17 atomic number and chlorine has 7 electrons in its outermost shell. So here it is and 7. Okay, and then it wants to acquire the stable noble gas structure. So in order to do that, it will just share the electron from the next atom of chlorine, and here the sharing, it will make a bond and it will form Cl2. So 1 electron is shared from one atom of chlorine and 1 is shared from the another atom of chlorine. So chlorine is reacting or is sharing one electron. That means the covalency of chlorine is 1. And if we talk about covalency of oxygen, so it is 2, because oxygen will share 2 electrons with the other oxygen atom, because chlorine, oxygen, hydrogen, all these are diatomic gases. Okay, so after that comes types of covalent bonds. Now we have 3 types of covalent bonding, that is single covalent bond, double covalent bond and triple covalent bond. All these bonds are covalent, but it differs that how many bonds are being formed in the covalent bonds. So first we'll be doing an example of single covalent bond, which is hydrogen. We'll take the example of hydrogen, which is H2, because again I've written H2, that means it's a diatomic gas. So hydrogen has valency 1. Hydrogen is only having 1 electron in its outermost shell, so it will always combine with the other hydrogen atom to share the electron. So the other hydrogen atom also has 1 electron in its outermost shell, and here it is sharing. There is no transfer of electron, okay, no gaining, no losing. It is sharing, mutual sharing is there. So this hydrogen will share the electron with this, and this will share electron with this, and because of this they bond together and they come close together. Now these covalent bonds are not as strong as the ionic bonds, because the covalent bond is not very strong. It is a weak bond. Now when it forms a new, it will be hydrogen, but it becomes a molecule. We don't call it as an atom, we call it as a molecule. So in this hydrogen takes 1 electron because it wants to attain the nearest noble gas structure as of helium, and it completes its duplet. So hydrogen will combine with the other hydrogen and it will form a bond. So it will be like this, hydrogen hydrogen, it will be a single bond. When this line is 1, that means it is a single bond and it will form a compound of H2. Okay, so next example we're going to take is of chlorine. So chlorine again is a diatomic gas, we know that, and chlorine has 17 as an atomic number, and the configuration 17 atomic number, and configuration is 2, 8 and 7. So chlorine atom here, if we take, I just explain you, 7 electrons and 7 in the next. So there will be a mutual sharing of electrons, and thus it will form a covalent bond, like chlorine here and chlorine here. So it will be Cl2. So this is also a single bond. Okay, so after this comes the next example of oxygen. Now since the oxygen molecule, we know that it's also a diatomic gas. Oxygen here has 8 atomic number and configuration is 2, 6, 2 and 6. So it has 6 electrons in its outermost shell, here 6 electrons. So it will combine with the other oxygen atom, which also has 6 electrons. So since oxygen needs 2 electrons to complete its octet structure, and this oxygen also needs 2 electrons, so they will not give these electrons to each other, they will just share. So these two will be shared by this oxygen atom, and it's from this oxygen atom the electron will be shared by this oxygen atom. So both the oxygen atom will be sharing 2 electrons from both of them. So it will be something like this, and it will be a double bond. Double bond because here oxygen is sharing 2 electrons from here, so there will be a double bond form. Right, I hope you understand. So when there is only 1 electron, it's a single bond. When there is transfer of sharing of 2 electrons from both sides, it's called as double bond. Now after this we come to the next example, like we'll take the example of nitrogen gas. Nitrogen, that is N2, and nitrogen has the atomic number 7, okay, and the configuration is 2 and 5. That means the nitrogen has 5 electrons in its outermost shell, 1. So 2 here and 1, 2 and 3 here, plus the other nitrogen is also having 5 electrons, 1, 2, 3 and 1 here. So these 3 electrons, I'll show you these 3 electrons like these. So they will be sharing the electrons like this. So it will become nitrogen 1 here, 1 here and 3 here, and the other nitrogen will also have 1 electron here, 1 here and 3 here. So it will be a sharing of 3 electrons from one side and 3 from one side. That means it will form a triple bond like this, because it is 3. So this is a triple bond. Okay, so it is N2 and triple bond. So I hope you understand the single bond, double bond and triple bond. Now we'll be taking some other examples like the formation of water molecule, the formation of ammonia molecule. So let's begin here. Okay, now water has 2 different elements like hydrogen and oxygen. So oxygen has atomic number 8 and hydrogen has atomic number 1. So the configuration of oxygen is 2, 6, and for this it's only 1. Okay, so how all these things bond? So here, because oxygen needs 2 electrons, it needs 2 electrons and it has 6, and here the hydrogen needs 1 electron. It has only 1 electron, so it needs 1 electron. So the hydrogen will take 1 electron from oxygen, this hydrogen, and this will take 1 from this. So they forms a bond. That means this hydrogen had only 1 electron and it wanted 1 electron to complete its duplet. So as this hydrogen has 1 electron and it wanted 1 electron, so it shared this, and here this oxygen got 1 from this and 1 from this. That means the oxygen got 2 electrons from 2 different hydrogen atom. So it formed a bond. That means it used 2 hydrogen and 1 oxygen to form a water molecule. If I'll explain you, it will be simple like this. It had, now these are the 2 because here hydrogen has shared. You can also make like this, and oxygen got is 8. So if you'll see here, oxygen had all the 8 electrons and hydrogen is having 2 electrons and this is also having 2 electrons. That means it's HOH, which means H2O, or we can also write HOH. So this is the, again, although it's a single bond, but this is also a covalent bond. Now another example we'll be taking of ammonia. Ammonia is ammonia molecule. So it is NH3. It's again very simple. Nitrogen has atomic number 7 and hydrogen has 1. It will be 2 and 5 and it will be only 1. So here will be 1 nitrogen and it will be sharing the electron with 3 hydrogen, because nitrogen has 3 electrons, 5 electrons in its outermost shell. So it will be having these 1, 2, 3, 4, 5. So it will be dealing with the different hydrogens. So this hydrogen has 1 electron here. Okay, now this has 1 electron, this has 1 electron, and this has 1 electron. So nitrogen also have these electrons. So it will just share the electrons. It will just share the electron from this, and this from this, and this from this, and so the nitrogen will also share the electrons like this. If you'll count, you'll see that 1, 2, 3, 4, 5, 6, and 7, 8. Nitrogen got 8 electrons, hydrogen got 2 electrons, this also got 2 electrons, and this also got 2 electrons. So everyone is having their electrons which they wanted to have by sharing. That means if we'll count here, nitrogen having configuration of 2, 8, it's stable hydrogen having configuration of 2, it's stable. The other hydrogen having configuration of 2, it's stable. And the third hydrogen is also having configuration of 2, it's also stable. Since they all get their required or their desired electrons, so they become stable and they form a covalent bond. So it will be like this: nitrogen, hydrogen, hydrogen, and hydrogen. So it's a single bond all the side, so it forms NH3. So this is how. Now one last example with you people I'm going to share is methane. So methane, ethene and ethine are the hydrocarbons which we'll be learning in this chapter in the next lecture. But before that, I want to tell you that this is a simple molecule of methane, 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 and this is a hydrocarbon. Hydrocarbon means when carbon forms bond with the hydrogen, it forms the hydrocarbon. Now methane is a single covalent bond. Since we have learned about the covalent bonds, so this is a single covalent bond, methane. So as we can see here, carbon and hydrogen, it is a hydrocarbon, and carbon has valency 6 and configuration of 2 and 4. Hydrogen has valency 1, so configuration only 1. So here this carbon has 4 electrons in its outermost shell. That means carbon has covalency of 4. So it will require 4 hydrogen atoms for sharing of electrons. So these 4 hydrogen atoms will share the electron like this. Okay, so every hydrogen is having electron, and the carbon will also have 4 electrons, although my drawing is not good. If you'll count here, 1 2 3 4 5 6 7 8, so carbon got its 4 electron, and this is how the bond is formed. So it becomes C and bond here, and this bond here, and this bond here. So C4, that means carbon and hydrogen. So CH4, it's, if we'll count, carbon has its octets complete. That means it got 4 electrons from sharing from the hydrogen. It got 2 and 8. All these hydrogen got 2 electrons, so they are also stable. So this is an example of single bond, and this is a hydrocarbon. Now, so after this, we will be doing next, that is ethene, C2H4, which is called as ethene. We have read about methane, and like methane, there is ethane. In the ethane, there are 2 carbons, and in this ethene, again, there are 2 carbons, but the name is ethene. It is because it is a double bond or double covalent bond. So there are 2 carbons, and these 2 carbon already share their 2 electrons with one another, and the rest remaining 2 electrons are being shared by the hydrogen. So 4 hydrogen will be sharing their electron. So this is how it will be formed. Okay, so this carbon will be having these electrons, and it will be like this, and this carbon will be having these electrons. So if you can see properly, if it is visible to you, I'll be using this sketch pen. So this is having so all these electrons will be taken by this. Okay, so each and every carbon got 8 electrons by sharing. So this forms the double bond. If it looks like this, so this is, and this hydrogen, so 4 here, so this is a double bond. So it's C double bond and H4, it's ethene. Okay, so next is triple bond. Triple bond. So triple bonds example would be ethine. This is also a hydrocarbon, ethene, which is C2H2. So here only H is 2, so C will be forming triple bond with the other carbon atom, and it will be using only one hydrogen to share the electrons, because carbon has 4 electrons. So all the electrons will be shared by like this 1 2 3 4 5 6 7 8. So it's complete, and this also will use like this. It's complete. So it will form a triple bond. That means C, triple bond with C and hydrogen. So it's C2H2. So this is all for today. I hope you understood all these covalent bonds. Covalent bonds are the bonds which are formed by the sharing of electrons of one atom to the other atom. And these are the chemical bonds. These are not that strong as compared to the ionic bonds, but they are very, very important to forming hydrocarbons, as the electrons which cannot share, which cannot transfer the electrons, they can form new bonds by this covalent bond. And this is of 3 types, that is single bond, double bond and triple bond. We have learned all these today. So I hope you understood, and please do question and answers and study hard. Thank you.